Hi, my name is Dan, and this video is one in a series of videos that I'm doing about simple uh, digital electronic circuits, uh, focusing on some what's called static circuits. And this is kind of early stages of getting going with some digital electronics and seeing how it relates to Boolean logic and similar things. So in this video, I'm going to do a couple of examples. And in fact, we're going to do what's possibly the hardest thing in digital electronics and in fact in computing, which is to go from the idea of a problem and to try and find a solution. Uh, Similarly in programming, and the same in digital electronics, it's very easy to see what different gates do and how to link them together. The real trick is to use these in a meaningful way to find solutions to real world problems, and working out how to deal with that. So we're going to tackle two particular problems. They're really simple problems, just to show you the kind of starting of ways of getting thinking in this sort of stuff. So the first example I'm going to do is a prison door. Here's a picture of a prison door. Um, so in this prison door example, we've got two guard posts, if you can imagine, one inside and one outside. Um, Actually, so it's not a cell door, it's kind of a main door to the prison. And in each of these guard posts, there's a door release button that a guard can press. Probably a nice big red button. There's a huge attraction to these big red buttons. And if a guard presses the button, then the door unlocks and the buzzer sounds. Okay, so we've got this idea: two buttons. They're both going to do the same thing, and for each of them, it's going to do two things. They're going to have a door unlock and a buzzer sound. Okay. So let's go to our digital work software and try and work out how to actually achieve this. Let's zoom in a bit. Why not? Um, so let's start by thinking, right, well, we've got two inputs. We've got these two buttons that the guards can use. Let's kind of separate them out a bit to indicate that they're in different places. It doesn't matter in the circuit. I can put them as close together as I like. And in fact, I am going to do that instead. I'm going to put them right up next to each other because the process that we want actually is quite simple. Um, and we want the activity to happen when either of these buttons is clicked. So we can the door will open if button A is clicked or if button B is clicked. Let's put some labeling in just to help us with this. So that's button A, and we're just going to do a quick copy and paste, and then edit that annotation to do button B. So that's just showing us what's going on. Let's put this a bit closer to the buttons. This text is just cosmetics, but it helps us understand what's happening. So the logic that we need behind this is it doesn't. We don't want this to happen when neither of the buttons are pressed. We want it to happen when either of the buttons are pressed. It doesn't matter if two guards press the buttons in the two different guard houses at the same time. So this is quite straightforward as an OR gate. So we can just plug an OR gate in there, connect it up. And so the output from this gives us the activity that we want. We've got two things that we want to happen. We want the buzzer to go and we want the door to unlock. And I'm going to put two LEDs in here. Snag them a bit. Again, I'm going to use annotations here so that we're clear on what we're actually representing. Hit the right thing. So that's the buzzer. And that's fine. When one of these buttons is pressed, the buzzer goes off. The door, I'm going to do that slightly differently because actually what we want with the door is that the lock being an electronic lock, when the power is on for the lock, that means it's locked. So we want that lock to disengage when the button's pressed. So we're just going to invert this. So I'm going to put a knot again in there and attach this. Here we go. Right, we've got simulation running already. So let's put another annotation in. Let's indicate that this is the door. Right. So when now the button is pressed, the door is active and the buzzer's not active. So the door lock is active and the buzzer isn't. And when you press button A, the buzzer goes off, the door opens. When you press button B, the buzzer goes off, the door opens. And you can see actually if both of them are pressed, that doesn't make any difference. But when none of them are being pressed, the door's locked and the buzzer's not going off. So that's quite a simple example. Actually, in terms of security, this would be the wrong way around, because if the power fails, you don't want the doors to automatically open, or do you? It's a security question. Don't know. Right, so let's get rid of that and let's go and see what example number 2 is going to be. So back to our PowerPoint slide. Let's zoom out back again. Oh dear, that was the wrong button. There we go. Example 1, example 2, go back. Right, British traffic lights. So, of course, these are the kind of traffic lights that I'm familiar with, being that I am a British person living in Britain. And British traffic lights go through a cycle of different symbols with the colours. Got a picture here to demonstrate that. So, uh, obviously, they're in the order: red at the top, yellow in the middle, green at the bottom. Yellow is sometimes called amber. Um, and when the red light on its own shows, that means stop, don't go. When it's preparing to be green in Britain, it doesn't just go straight from red to green. It has this phase which is red and yellow, which tells you we're about to go green. You can get yourself ready. You can put your car in gear, uh, uh, etc. And that only holds there for a couple of seconds before it turns to green. And then when it's when it's going to go red, it shows the yellow light on its own. So we've got red, then red and yellow, then green, and then yellow on its own. Right. So we're going to produce a circuit which will do this for us. And we've got 4 phases, and we're going to do this using 3 lights, obviously. 4 phases, 3 lights. Let's go back to our digital works circuit. Here we go. So we've got nothing on here at the moment. And the way that I'm going to do this in this video is that I'm going to use separate inputs for the 4 phases, and I'm going to basically imagine that you're only going to have one of these inputs live at any one point in time. Let's just, again, zoom in a bit. There we go. And so I'm going to put in 4 inputs. I'm just going to stop simulation. 1, 2, 3, 4. So these 4 inputs, these represent the 4 phases of the traffic lights. Only one of these is going to be active at any one point in time. And then let's put our lights over at the right hand side. Put in 3 LEDs. And in fact, in Digital Works, we can change the colour, which is quite handy because we can have a yellow light and a red light, green light as well. There we go. So let's have a little bit of thinking about this. The red light, let's go back to our image of this. Oh dear. This is what I get for zooming in, isn't it? Let's go backwards. Right. So the red light is active in phase 1 and phase 2. So either phase 1 or phase 2, the red light needs to be active. So that's actually quite straightforward. Zoom back in. These are the phases 1, 2, 3, 4. I could label them, but I can't be bothered. And I'm going to put an OR gate in for our red light. I'm not going to bother with making this all neat and tidy because I don't have a huge amount of circuitry to put in here. And let's zoom back out again and go and look at our thing. So the yellow light, when's that active? Phase 2 and phase 4 for the yellow lights. Okay. Back we go. zoom in. So we need another OR for our yellow light. Let's just attach that up. And what did I say? Phase 2. So we're just going to tap off that wire there. And phase 4. And finally, I can remember phase 3 is the green light, and there's only one phase. It's the only one light that's on at that point in time. So let's have a quick look. If I press play, and let's go through the phases. So phase 1, red lights. And phase 2, red and yellow. Phase 3 for the green, and phase 4, just the yellow light. So we've gone from a problem here to a solution. It's quite a simple problem and quite a simple solution because we've just got the two gates here. We had a previous one which is even simpler, which is our prison door thing. And I hope you've seen how I've gone through the process of thinking about what the outputs need to be depending on the inputs, and then deciding what gates that I need to have in there as a result. In the next video, I'm going to show you how to do a bit more advanced stuff in the same line using truth tables. And we're going to visit this traffic lights problem again, but we're going to use, instead of using 4 phase inputs, we're going to use a binary input. And we'll look at a somewhat more complicated problem again using binary input. But that's the next video. So that's it from me for now.